Welcome to this tutorial. This is part 3 in this series focusing on Boolean logic, truth tables and logic gates. Previously we've looked at basic logic gates and basic truth tables. Now we're going to move on to looking at logic gates in series. What that means is where one logic gate feeds into another. So now notice on the screen I've got an AND gate, there it is, and I've got a NOT gate, there that is. And if I move those into series, so one feeds into the other, notice that there are no inputs and there are no outputs at the moment. So I'm going to apply an input to my AND gate, and because it's an AND gate it requires minimum of two inputs. There we are. So I've got two inputs. Now I'm going to have an output at the end of the series, so there we are, and I'm going to join the NOT gate to the light bulb. Now notice that there's nothing happening with the light bulb yet because there's no connection between the AND gate and the NOT gate. Now let's make a connection to the two gates now. So we can say that the light bulb is off. And the light bulb is off, of course, because we've got two positive inputs to the AND gate, or both of our inputs are 1. So that produces an output of 1, but that then feeds into being an input of 1 to the NOT gate. And of course, a NOT gate is an inverter. It flips the value, so its output would be 0. So that would therefore ensure that the light bulb, or the output, is off. Now, I'm going to remove one of the inputs from the AND gate, and I'm going to replace it with another one, but the value being 0. Now notice that the light bulb has gone on. I'm just going to get rid of that. Yep, light bulb is off. I make that an input to the AND gate, light bulb, or the output comes on. That's because we have an input of 1 and 0 to the AND gate, which produces an output of 0 at the AND gate, which feeds into the NOT gate, of course, producing an output of 1. So let's take away that and take away that and remove that input. Move that input from the AND gate. Now, theory should be that if I have two inputs to my AND gate, both being off, both being 0, then the output will be 0. If the output from the AND gate is 0, the input that will feed the input to the NOT gate, and it will produce an output of 1 on the NOT gate. So let's try that. There we go. So there's no change. So what we've got, of course, is our AND gate is producing 0, our NOT gate therefore is producing 1, and our light bulb is on. Okay, so that's an AND gate and a NOT gate in series. Let's have a look at an OR gate and a NOT gate in series. Okay, so I'm going to pull an OR gate onto the screen. There we go. And I'm going to produce a NOT gate onto the screen. We need our output, so I'm going to use a light bulb on this occasion. Now, of course, nothing's happening to it yet because nothing has been joined. I'm going to have an input of 1 to the OR gate. Now, just with the one input, I'm going to join that to the NOT gate, and nothing is happening. Nothing is happening, of course, because if I have a value of 1 going to my OR gate, then that will produce an output of 0. And the same, of course, if I have two inputs of 1, it's still producing a 0 as the output, which then becomes, of course, the input of the NOT gate, which produces the 1 as an output. Now, so let's change that. Let's take that out and remove that. And now the theory being that if it's a 1 or a 0, the output should not change. There we are. The output hasn't changed because, of course, because the output of the NOT gate is the OR gate rather is still 1, which makes the input, or the output rather, of the NOT gate. There we are. NOT gate 0. Now, so if I just remove that one and I replace that with a 0, let's just drag that one across. There we go. So now I've got two inputs to my OR gate. Both of them are 0, or both of them are off. So that produces an output of 0 at my OR gate. Output of 0 becomes the input to the NOT gate, and that therefore is 1. If it's an output of 1, that will fire the light bulb. Okay, so we've now looked at how to work with two logic gates in series, an AND and a NOT, and an OR and a NOT. Okay. The next thing we will start to look at is working with logic gates in parallel. So we've just looked at them in series, we're going to look at them in parallel.